Hello, my name is Lizzie Mabe, and I'm a data scientist with the Cloud Data and Analytics team at SAS. In this video, I'm going to show you how you can use SAS Viya Workbench to improve performance and productivity through a real-world example using customer churn data. But first, what is SAS Viya Workbench? Workbench is a lightweight, on-demand cloud development environment in which users can choose the amount of compute necessary for their project and their preferred coding language.
Currently, Workbench supports coding in SAS and Python through Jupyter Notebooks and VS Code. Support for programming in R and through additional clients are expected to be added in the future.
One of the main benefits of SAS Viya Workbench is its centralized development across a range of users. SAS and open source developers can both code in the same environment and collaborate using GitHub for distributed version control. This is all done in a lightweight implementation in which the users themselves can limit their cloud costs by selecting only the amount of compute they need and only using it when they need it. With SAS Viya Workbench, users also have platform optionality, meaning they can tailor their environment to their specific needs and are not locked into a cloud or data provider. Finally, Workbench can enhance performance through SAS's best-in-class analytics. Workbench currently contains an extensive list of SAS procedures covering a full range of data and analytics functionality, and will continue to grow to cover all of SAS's AI and analytics technology. Open source programmers can achieve faster results as well by leveraging SAS analytics through APIs for Python with nearly identical syntax. Currently, Workbench contains Python APIs that cover the most common statistical and machine learning methods, with open source capabilities continuing to grow as well. Users can deploy multiple workbenches to accommodate a wide range of compute tasks, and these workbenches can then be connected to the enterprise SAS Viya environment to share, govern, and deploy assets. By connecting to the enterprise analytics platform, development in Workbench can be serviced and managed across the organization. Now I'm going to demonstrate how you can quickly spin up a workbench to perform data preparation and modeling using both SAS and Python languages. I'll start by examining the settings to select my maximum compute. Users can easily update their compute settings if their project requires more compute than anticipated. The workbench can then be opened in Jupyter Notebook, Jupyter Lab, or Visual Studio Code. I'm going to select Visual Studio Code, which contains both SAS and Python extensions, allowing me to code in both languages in the same environment. The workbench spins up in under 20 seconds, allowing me to start working right away. I'm now going to do my data preparation and exploration in a SAS notebook. This notebook exclusively uses SAS code, but if I had other languages installed within my SAS extension, I could switch the cells to SQL or another language. I'm interested in preparing the data for modeling and finding out some preliminary information about customer churn. First, I'll import my data from a CSV. In Workbench, I also have the ability to pull in data from Oracle, Postgres, Snowflake, and other databases using SAS Access engines if that's where my data is stored. I will now run my code, using SAS procs and data steps to import the churn data, drop unnecessary variables, and impute missing values. I also observe the frequency of lost customers and see that about 6% of customers in the data have churned. I've also created a plot showing that customers who have churned have a lower average purchase amount, meaning customers spending more money per purchase are more likely to stay. I could continue with the modeling process in SAS, but I want to demonstrate how those more comfortable coding in Python can easily take advantage of SAS analytics by exporting my data and moving over to a Jupyter Notebook for modeling. So now I'll switch over to the Jupyter Notebooks tab, where we'll see an interface that is likely familiar to Python coders. I'll import the necessary libraries and read in my clean data that I just exported from my SAS notebook. I can now execute my Python code to create and compare models. I'll begin the modeling process by creating target and predictor sets and dividing the data into training and test. I'll also one-hot encode the categorical variables and use SMOTE to create balanced data between events and non-events. Finally, I'll run a random forest model using both the Python API for accessing SAS analytics and Python's built-in random forest classifier. as you can see, the syntax between the two models is nearly identical. After running the models, we can compare the results in terms of speed and accuracy. Looking at the runtime for each random forest model, we can see that compared to the Python model, the SAS model took less than half the time to run. For compute-intensive workloads, this improvement in runtime can significantly reduce cloud computing costs. To compare model performance, we can look at the AUC, with scores closer to 1 being more accurate, and see that in addition to being faster, the SAS model also outperformed the Python model in its ability to identify customer churn. So, with SAS Analytics, we are able to get quicker, more accurate results. Finally, we can export the SAS model as an AStore file, which can be used to automate the post-model development phase of the model lifecycle. This brings us full circle to the power of integrating SAS Viya Workbench with the SAS Viya ecosystem. Models created in Workbench can be registered with SAS Model Manager, where you can observe model properties, comparison and versioning, perform scoring tests and monitor performance, and easily publish for deployment and integration with SAS Viya's enterprise decisioning, workflow applications, and post-processing analytics and visualizations. With SAS Viya Workbench, both SAS and open source coders have the power to gain faster and more accurate results, control their own compute costs, and access SAS Viya Enterprise for automation and governance to ensure trustworthy analytics are being performed at each stage of the model lifecycle.